Ever wondered what powers the undo button in your text editor, or how your printer just knows which document to print first? Well, the answer lies with two of the most fundamental data structures in all of computer science: stacks and queues. So let's dive in and see how these things are secretly running our entire digital world.
We're going to start with something we all know, something incredibly familiar, a simple line, right? Whether you're waiting for coffee, a movie, whatever, the principle is always the same. The first person who gets in that line is the first person who gets served. Just keep that idea in your head.
So what on earth could that line possibly have in common with a stack of plates in your kitchen? I know, it sounds like a weird question, but the answer reveals these two simple but incredibly powerful rules that organize a huge part of our digital lives. So here's our game plan for this explainer. We'll start with that tale of plates and lines to really nail down the two golden rules. Then, we're going to peek under the hood to see how they're actually built, find some of those aha moments where you use them every day, and finally, we'll look a little beyond the basics.
Okay, it all starts right here. These are the two core principles that define everything about how stacks and queues work. The only real difference between them comes down to the answer to one simple question: which item do we take out?
And this lays it out perfectly. A stack that follows the LIFO rule. Last in, first out. You add to the top, you remove from the top. Simple. A queue, on the other hand, follows the FIFO rule. First in, first out. You add to the back, but you remove from the front.
Let's make this real. A stack is exactly like a stack of plates. When you wash a plate, you put it on top of the stack. And when you need a plate, you don't dig all the way to the bottom, right? No way. You take the one right off the top. The last plate you put in is the first one you take out. That's LIFO.
And a queue, well, that's our movie line. The first person who got there is the first one who gets a ticket. It wouldn't be very fair to serve the person who just showed up, right? It's all about order. First one in is the first one out. That's FIFO. See? It's simple stuff, but it's incredibly powerful.
Okay, so we've got these two simple rules, and they're easy enough to get with plates and lines, but how do we actually build them in our code? You know, what are the architectural blueprints that bring these really elegant ideas to life?
Well, it usually comes down to two common building blocks. You've got linked lists, which are kind of like a chain of connected nodes, and you've got arrays, which are more like a fixed set of numbered boxes. And as you're about to see, they both have their pros and cons.
Now, check out how elegantly a linked list handles the stack. To push or add a new item on top, you just make a new node, point it to whatever the old top was, and then just declare it the new top. It's this super quick, clean, four-step shuffle of just updating the links in the chain. Now, the other popular way is just using an array, and at first glance it feels a lot simpler. You just add stuff to the next open slot. But this simplicity, it kind of hides a critical weakness. There's a catch. And here it is: overflow. An array has a fixed size. So what happens when you try to push just one more item onto a stack that's already full? You've run out of boxes. This is the major downside of using a simple, fixed-sized array. So what this really shows us is a classic trade-off. On one hand, a linked list is always fast for every single operation, but each item uses a little extra memory for those connecting pointers. On the other hand, a resizing array is fast on average, but every once in a while a single push can be painfully slow if it has to stop and copy everything to a brand new, bigger array. It's a classic engineering choice. Do you want guaranteed speed or overall efficiency? Okay, we've covered the rules, we've covered the blueprints. Now for the fun part. Let's see where these concepts actually show up in the tools you use all the time. This is where those abstract ideas of LIFO and FIFO are really going to click, because I promise you've been using them for years without even knowing it. Every single time you hit the back button in your browser, you are literally popping the last web page you visited off of a stack. When you hit undo, you're popping the last action you took off a stack. Even the very way computer programs run, calling functions inside of other functions, is all managed by a massive hidden stack. And, you know, getting these designs right is tricky, even for the experts. This is a fascinating bug report from back in 2001 about Java's built-in stack. They basically admit the initial design was flawed, but they couldn't fix it because too many other programs already relied on the mistake. It's a perfect example of what engineers call technical debt, where a bad decision you make early on has to be paid for, with interest, for years and years. So what about queues? Oh yeah, you use them constantly. If you've ever sent a bunch of documents to a printer, you've used a queue. The first thing you sent is the first one that prints. Web servers use queues to handle all of our requests in the order they arrived. And the video you're streaming right now, it's using a queue to buffer data to make sure you get smooth playback.
So we've seen just how fundamental these tools are. But the story doesn't stop there. Programmers have come up with some really clever enhancements that make these simple ideas even more flexible and efficient. Let's just touch on a couple of those.
First up, something called generics. So instead of building a stack of strings and a stack of numbers and a stack of URLs, generics let you build one stack of literally anything. It's a reusable blueprint that helps you avoid dumb cut-and-paste errors, which makes your code so much safer. It's all about a key idea. It is always, always better to find errors while you're coding than to have your program crash on a user later.
And for queues, there's this brilliant optimization called a circular queue. A regular queue built with an array can waste a ton of space at the front as you take things out. A circular queue cleverly fixes this by just wrapping around. When it hits the end of the array, the next available spot is right back at the beginning. It's such an elegant way to maximize your memory and cut down on waste.
So, wow, we've covered a lot of ground. We started with some simple analogies, we looked at the real engineering trade-offs for building these things, and we saw how they secretly power the tech we use every single day.
But at the end of the day, all of this complexity, from your browser history to managing massive web servers, it all boils down to those two golden rules we started with. Last one in, first one out. Or first one in, first one out.
And that kind of leaves us with a final thought. Stacks and queues really show us how an incredibly simple foundational rule can be the basis for amazingly complex and powerful systems. It really makes you wonder, doesn't it? How many other parts of our digital lives are just like that, built on one simple idea, just waiting for us to find it?